desperately need people with passion, people like us in this room today, to commit and go out on a limb and become sort of crusaders, perhaps faintly unpopular. And I know that our next speaker would never, ever, ever be described as unpopular, but I think he wouldn't mind being described as a crusader. I first had the pleasure of hearing Ken speak in Singapore some 5 years ago. And he gave us a very stimulating address on the challenges facing design in producing green architecture, but more than that, sustainable built environments. So I'd really like you to welcome Ken, because he has gone where others have not dared to go earlier, and he has led the charge, and certainly in Asia at a time when Asia was not renowned for advancing a sustainable agenda. So please welcome Ken Yeang.
I'm going to talk today not just about green design, but the ideas, propositions, and experiments that I've been involved in for the last 3 decades or so. One of the first things that influenced my design of skyscrapers or tall buildings is the need to be stratified from a mechanistic type of building to a more organic one. And what do I mean by this? This is a stack of plates in somebody's kitchen. And this is exactly what most architects are doing when they design skyscrapers, designing a homogeneous floor plate stacked on top of each other, exactly looking like this. Now, what you get is...
Speak up? We can't hear you.
Sorry, so that I speak. Maybe you should turn it on. But I will try and speak a little bit louder, maybe close to the microphone. But what you get is, with the conventional skyscraper, is an instant stratification, like you see in a diagram on the right-hand side. Thank you, that's much better. So now with the conventional skyscraper, what you do is that you go to this space called a lobby and you press the button, then magically a steel cabin comes down, you get into it, you press the floor that you want, and you get to the level that you want. Now I always saw this as an unusual and inhuman way of creating round buildings. Now, if you were to live in or use a low-rise or medium-rise building, then what you get is a much more organic movement between space. You can freely move between one to the other, and you don't have to go to this mechanistic way of pressing a button going up the top of the building. And so my challenge to architects and engineers who design skyscrapers is that why can't you design your skyscrapers like the way you design low-rise and medium-rise buildings? The answer is yes. But why don't you do it? It makes a much more humane and much more habitable space. And so this is one of the ideas that I started with. And I said, let's not design skyscrapers as homogeneous stacking plates, one on top of each other, giving us instant stratification. But try and design skyscrapers in a much more organic way, in the same way that we design low-rise and medium-rise buildings. And so I started to think, well, why can't you design skyscrapers in a way that you do urban design? Now, if you take a site of about 20,000 square foot, I'm sorry, this is not metric, I use square foot, and if you have a gross floor area plot ratio of 1:12, then what you have is the potential to build a 240,000 square foot building. Now, if you have a floor plate of about 10,000 square foot, what you have is a 24-story building. Now, if you spread it all out in a single-story building, what you have is a building of about 6 acres. And if you ask an architect or a planner to design something on a floor plate of 6 acres, what you have is not architecture anymore. What you have is urban design. So all the key aspects of urban design comes into play. And so this is, if you like, a plea not to design skyscrapers as homogeneous floor plates, as fortresses on island sites, but to reconnect it. In other words, see skyscraper design as vertical urban design. That means take everything that you find pleasurable at the ground plane upwards. So all the principles that you understand, that you know about urban design, like placemaking, creation of public realms, figure ground relationships, creating communities, accessibility, open spaces, landscaping, and creating business and so forth. What if you flip it vertically? What does it mean? What does placemaking in the sky mean? What does public realm in the sky mean? What does figure ground relation in the sky? What does it mean by creating communities in the sky? So this is a challenge, and this is the proposition that has been occupying me in our work, and that I hope that this will stimulate you into rethinking a different way of designing skyscrapers. And so instead of doing skyscrapers as a homogeneous place, what you have is a superburger with different things in the building, stacking all the way up, if you have to go up. And to make it pleasurable for people. And that's why, about 20, 30 years ago, there was a reaction against skyscrapers because they were just terrible places to be in. And it reminds me of something that a famous Sri Lankan architect, Geoffrey Bauer, said just before he died. And somebody asked him, Mr. Bauer, what is architecture all about? And Mr. Bauer said, architecture is about making people happy. I think this is what we have to do. That not only do we design buildings that function, that make our clients money, we have to design skyscrapers that make people happy. And so these were some of the early work that we did. We said, look, one of the first things you need to do is not to put everything in the ground plane, but to have multiple programs in the sky. In other words, why can't you have the pub in the sky? Why can't you have the gallery in the sky? Why can't you have schools in the sky? Why can't you have the chemist or the corner news agent in the sky? And so in this way, we're recreating what we find pleasure in the ground plane up in the sky. So here's a scheme that we designed somewhere in Europe, where we suggested that instead of having a park, parks surrounded by buildings, recreate a park first and put the buildings in, and try and recreate these pleasurable, different multiple programs in the upper parts of the building. Within the site, this is our signature tower. We can see the study diagrams, the ideograms, if you like, in the first two diagrams, and then define the scheme on the right-hand side. And so the idea would be to have multiple programs in the sky, create multiple open spaces in the sky at different levels, and have multiple accessibility. This is a stack of magazines that came in somebody's kitchen again, and said, well, of course you can do this. Let's rotate the floor plates, and let's create sort of interesting spaces. This was a scheme that we designed in Tokyo, commissioned by Mr. Kurokawa, which unfortunately will not be built as he died a couple of months ago. These were our structural studies for the scheme, and the idea would be to have a track on the outside where you have this cherry picker that services the building from the outside or services the parts from the outside. How about greening the skyscraper? Biodiversity is an extreme point factor because in nature you have both organic components and inorganic components, or in fact in ecosystems defined as barking components and abarking components acting together to form a whole. Now if you look at a building like what we have now here, everything in this building is inorganic. The only thing that's organic is you and me and the bacteria and the bugs. And so if you keep building like this, the whole world becomes increasingly artificial. So the idea of putting vegetation buildings was something that intrigued me, and I started looking at different ways of doing this. And so this little diagram shows you can put all the vegetation in one location, a number of sky cards, which are called juxtapositioning, or you can have a much more spotty relationship, like intermixing, or you can have integrated relationships. You can see the bottom right-hand diagram. From the ecologist's point of view, the bottom right-hand diagram is the preferred one because it enables species migration, and it enables better interaction between species, and engenders a habitat with greater resources for sharing between the species, and therefore generates a much more diverse and stable ecosystem. These are the buildings that we did a few years back, where we started to put vegetation on the outside of the building, and when it was completed, it was referred to as the hairiest building in the world. Now this image is also emblematic for me, because I believe that the skyscraper, or the building of the future, the green building of the future, will not look like a conventional autonomous building. It will be fuzzy, it will be hairy, and it will be an integration of organic and inorganic mass. Now the other day I was in Vancouver, and I was driving down the street with my client and a local architect, Mr. James Chang, and he pointed out the building to me and he said, this building received LEED Platinum Award. And my client said, well, it looks like any other building. And so, this is what a lot of architects and engineers have been doing. They just take any old building design, stuff it with all sorts of eco-technology, with photovoltaics, recycling systems, wind generators, and say that's a green building. But it doesn't look like a green building. I think explicitness in green buildings is extremely important, and then trying to make a building look green is just as important as adding all this technology to it. This is the floor plate of the building. You can see I have terraces all the way around the edges of the building, and that's where the greening takes place at the edges. But the idea of spiraling, of integrating building, green with buildings was something that, again, sort of intrigued me. And this was the design we did for a building in Singapore, where we had a ramp that circles entirely around the edges of the building, and then we brought vegetation from the ground, working its way up to the top of the building. And then at the top of the building, we have this contained with this sort of shell, which collects rainwater for harvesting rainwater. And in addition, we have scallop-shaped sunshades that collect the rainwater for harvesting rainwater. The idea of creating places in the sky was something that intrigues us. And so at the same time that in the way that we brought vegetation up the building, you cannot do this always on the outside of the building. So with this scheme in Abu Dhabi, what we did was to have a series of atriums that are linked and weave its way up to the top of the building, and then in the upper parts of the building, we create pleasurable spaces like these, so that what we find pleasurable in the ground, we find up in the sky. Now, a couple of weeks ago, well, not a couple of weeks ago, some time back, the British Council gave a lunch in which the guest of honor was the Duke of Gloucester. The Duke of Gloucester, as you know, is the cousin of the Queen of England, and used to be an architect before he gave up being an architect for his royal duties. I had just written a book about, which I call The Vertical Theory of Urban Design, because I was an architect, I was placed next to him over lunch, and I gave to His Royal Highness, I said, Royal Highness, here's my latest book, which I hope you read as an architect, and it's about rethinking the skyscraper, a vertical theory of urban design. Then he looked at me and looked at the title, and he said, oh, Ken, that reminds me of my definition of dancing. So I said, well, Your Royal Highness, what is your definition of dancing? Well, I said, dancing is for me the vertical expression of horizontal desires. And I said, that's what skyscraper design should be, the vertical expression of horizontal desires. And so this is, well, this rises to the occasion, but it's the skyscraper we design, and what we try to do is to recreate the pleasures in the upper parts of the building. Now, then I talked about the skyscraper in the same way that at the ground plane for a site with a large footprint, we would have multiple accessibility. Why can't we design skyscrapers with multiple accessibility? Why can't we shouldn't have just one single bank of elevators, even though you have transfer floors? We should have secondary banks that maybe have 10, 12 floors. We have tertiary elevators, movement systems within the 10, 12 floors. So maybe 4 or 5 floors, or maybe even quaternary systems of ramps and small elevators that say 2, 3 floors. This is one of our early designs for a 500-meter skyscraper, and that again the idea was to have a promenade that weaves its way up the building in the same way that the city has a promenade, vegetation strategy that works its way up again with paths in the sky, a prime circulation system, elevators, then a mass transit system, a light transit system, rail system like you have in the Alpine railway lines that weave on the outside of the building with stations in between, tertiary circulation system, quaternary, and then horizontal and vertical zoning as well. So I'm going to end in a minute. I'm going to talk a little bit about the idea of some of the experiments we've done in designing the naturally ventilated skyscraper. One of the thoughts we had is, why can't we have wind ducts to capture the wind and ventilate inside the building? And so here's a scheme that we designed in Penang, in Malaysia. And now we designed this as a naturally ventilated skyscraper by default and not by design, because the client says, well, how much does it cost to build this building? I said, well, it costs you so much per square foot. And he said, why is it so expensive? And I said, that's because you have to put all these things to make it comfortable. And he said, well, could you make it cheaper? Well, I said, well, if you if you take out the air conditioning system, and I said, and people come, the occupants that come in, will bring in their own air conditioning condensers, and you reduce the cost of building. So I said, right, well, let's take out the air conditioning system. I said, then he says, could you make it cheaper? I said, well, we'll take out the windows. I said, no, we'll keep the windows, we'll take out the air conditioning system. And so, what we thought is that, said to my lads, well, why don't we design this as a naturally ventilated skyscraper, so that in the event the owner wants to put in the air conditioning system, we could put it in. So we had this idea to use what we call wing walls. Wing walls. Wind wing walls. Like the name of your Chinese neighbor. Now, the idea is very simple. If you have a wind that hits the incidence of a building, then by A, what the wind enters, obviously small a. But most times, as you know, the wind hits the surface, the facade of the building at an incline, B, and then the air that you get into the building is small b. And obviously A is bigger than B because it's an incidence to the facade. So the idea was that what happens if you have a wing wall, a little fin that captures the wind, then the wind that enters the building C is obviously bigger than B and bigger than A. And so what you see on the bottom left-hand side is an idea that you have two wing walls, you capture the wind, and then you get B coming to the building. And obviously another idea would be to have the wing wall right in the middle, that you can capture wind from all directions. And so here's the scheme, here's the floor plate, and what you have is two wing walls with a wind pocket, a balcony that captures the wind, and you have sliding doors to moderate the wind coming in. Now don't forget, this is not in London, this is not in Europe, not in the US. This is Malaysia, which is not first world, was not third world either. I'll call Malaysia 2.5 world. And so, with this sort of situation, it's a very primitive idea, and that we would have sliding shutters with these wind pockets. So we simulated this, and we look at the effects of wind on the facade. You can see the wind accumulating in section, then in plan again the wind accumulating at the wind pocket and turning towards the end. And so this is the comfort conditions on the inside. You can see on the left-hand side the comfort conditions without the wing walls, and then on the right-hand side the wing walls are open. You can see the wind whooshing right through at the bottom of the floor plate and coming in. And so the idea led us to develop this graph, where on the bottom we have wind speeds in meters per second on the bottom axis. On the top axis we have percentage of the windows that are open, and then we look at the windrows at different levels, and we plotted the graphs for different facades. So you can see the graph of the south windows, the graph of the north window, and the graph of the east windows. And on the left-hand side we have different air changes, from 1 air change per hour to maybe 10 air changes. And so now you can imagine that the shutters next to the wind pockets are monitored and automated. And that at any point in time, if let's say the wind speed on the outside is at 6 meters per second, as you can see the lower axis, and it hits on the north facade, and then at a particular point we draw the line across, then it automatically opens the facade at 40–50% of the facade to be open, and you get your 5 air change per hour. So this was the beginning of the potential for a national ventilated skyscraper.